Good day everyone. Hi, I am Jeremy Motor, and I am going to teach you all about the principles of mathematical induction, the sigma notation, binomial expansion using Pascal's triangle, and lastly, arithmetic sequence and arithmetic series. So enjoy watching my video. So we are going to tackle all about the principles of mathematical induction. So what is principles of mathematical induction? So it is a method for proving statements about natural numbers. So there are two steps involved in this principle. First one, the statement is true for natural number 1. And the next one is, if the statement is true for some number k, it is also true for the next natural number k plus 1. And now, we are going to prove this given by using the PMI, or the principles of mathematical induction. So 1 cube plus 2 cube plus 3 cube plus dot 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 n cube should equal to is equal to n squared times n plus 1 squared over 4. So the first step we should do is that let us show true for n is equal to 1. So we are going to use this equation here. n cube is equal to n squared n plus 1 squared over 4. So we are going to do, what we are going to do is, we need to substitute 1 for all the n's in the equation. So 1 cube is equal to 1 squared plus 1 plus 1 squared over 4. So 1 cube is simply 1. 1 squared is 1. 1 plus 1 squared, 2 squared is equal to 4 over 4. So 1 times 4 is equal to 4 and over 4. So 1 is equal to 4 divided by 4 is 1. So this is equal. And the next step we should do is show, let us assume that n or any n here is equal to k. So we are going to substitute this with k. So 1 cube plus 2 cube plus 3 cube plus dot 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 k cube, and we are going to also to substitute n with k. So k squared plus times n plus 1, k plus 1 squared all over 4. After assuming that n is equal to k, let us show that k is equal to k plus 1. So, show k is equal to k plus 1. And let us substitute all the k's with k plus 1. So 1 cube plus 2 cube plus 3 cube plus dot 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 plus, k cube. And what we are going to write after k cube is the next natural number wherein k is equal to k plus 1. So k plus 1 is cube, diba? We are going to substitute all the k's with k plus 1 equal to k plus 1 squared times k plus 1 plus 1 squared all over 4. So this is simply k plus 1 squared times k plus 2 squared all over 4. Now, this variable here, this terms here is equal to this equation. So bring down k plus 1 cube, and we all know that this here is just simply k squared times k plus 1 squared over 4. So we are going to put this here. So k squared times k plus 1 squared plus over 4 plus k plus 1 cube. So we need to prove that the right term is equal to the left term is equal to the right term. So the LCD of both of these is 4. So over 4, 4 divided by 4, 1. So 1 times this value is the same. So k squared times k plus 1 squared. 4 divided by 1 is 4. So 4 times this is plus 4 k plus 1 cube. K squared times k plus 1 squared plus 4 times k plus 1 cube should equal to, over 4 should equal to k plus 1 squared times k plus 2 squared all over 4. So we should prove that this is equal to this. And we can notice that we can extract k plus 1 from this equation. So k plus 1 squared times k squared plus 4 times k plus 1 over 4, and write this down, k plus 1 squared k plus 2 squared over 4. So we can distribute this 4 with k plus 1. So k plus 1 squared times k squared plus 4k plus 4 all over 4. So k squared plus 4k plus 4 is an expansion of the binomial k plus 2 squared. And bring down the others, k plus 1 squared all over 4. So we can notice that the value in the left side is equal to the value of the right side. So k plus 1 squared times k plus 2 squared plus 4 is equal to k plus 1 squared times k plus 2 squared all over 4. So we proved that the given 1 cube plus 2 cube plus 3 cube plus n cube is equal to n squared times n plus 1 squared all over 4. So this is how you prove a given using a PMI, or the principle of mathematical induction. Our next topic for today is all about sigma notation. So what is sigma notation? Sigma notation is a shorthand for writing sums. It denotes sum. So the uppercase letter or Greek letter, this letter, which is called sigma, is used to indicate a sum. So we have here an example of a sigma notation. So this illustration here is, or can be called as, the summation of fi from I is equal to 1 to n, wherein I is less than or equal to n. A sigma notation has 3 properties. So when the variable has an exponent of 1, the formula we will be using is n times n plus 1 over 2. When the variable or the number has an exponent of 2, the formula we will be using is n times n plus 1 times 2n plus 1 over 6. When we have a variable or a number that's the exponent is cube or 3, we are using this formula, n squared times n plus 1 squared all over 4. We have here an example of a sigma notation. So the first example is that we have a variable with an exponent 1. So we are going to use the formula n times n plus 1 all over 2. So we know that our n is 50. So let's substitute all n with the value of 50. So it's equal to 50 times 50 plus 1 all over 2. 50 times 51 is going to be equal to 2,550. 2,550 over 2 is simply 1,275. So the summation of I from I is equal to 1 to 50 is 1,275. In this next example, we have a variable with an exponent of 2. So we are going to use this formula, n times n plus 1 times 2n plus 1 all over 6. So the same with the previous example, we are going to substitute n with this value. So our end here is 50. So 50 times 50 plus 1 times 2 times 50 plus 1 over 6. So simplify 50 times 51 times 101 over 6. Or we can write it like this. So 50 times 51 is 2,550 times 101 over 6. So 2,550 times 101 is going to equal to 257,550 over 6. So 257,550 divided by 6 is equal to 42,925. So the answer for the summation of I squared from I is equal to 1 to 50 is 42,925. So we have an example with an exponent of 3. And when it's cubic, the formula is n squared plus n plus 1 squared all over 4. And with the previous example, we are going to substitute n with its value. So 50. So 50 squared times 50 plus 1 squared all over 4. So 50 squared is going to be 2,500. 51 squared is 2,550 all over 4. So 2,500 times 2,550 is equal to 6,375,000. And we are going to divide it by 4. So 6,375,000 divided by 4 is equal to 1,543,750. So the summation of I cubed from I is equal to 1 to 50 is equal to 1,543,750. The next topic we are going to tackle is all about the binomial expansion using the Pascal's triangle. So what is Pascal's triangle? It is a triangular array of binomial coefficients named after the famous mathematician Blaise Pascal that lived from 1623 to 1662. So the properties of Pascal's triangle is each number is the sum of the numbers above it, and the outside numbers are all 1. So as you can see in this Pascal's triangle, the outside numbers are all 1, 1, and 1. And each number is the sum of the numbers above it. So 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, and 1 plus 5 is 6. Let's try an example. Let us expand x plus y to the power of 6. So we have an exponent 6, and it's not easy to solve that. And we are going to use the Pascal triangle. And we are going to use this line here. So it is line number 6 because the exponent is number 6. So 1, 6, 15, 20, 15, 6, and 1 are going to be our coefficient. So 1 times, okay. So the pattern here for x and y is that x starts from the very, the large or the highest exponent. So from 6 going down to 0. So the x variable is in descending order, while the y variable is in ascending order. So y starts from 0 up to 6. So this is our first term. 1 times x to the 6, y to the 0, plus 6 times x to the descending order, so 5 times y ascending order 1 plus 15, okay, so the same descending order x, 15 times x to the 4th times y to the 2nd. plus 20, our next coefficient, so 20 times x cubed times y cubed, and plus our next coefficient 15 times x squared y to the fourth, and our next coefficient is 6, so plus 6x to the first, y to the fifth, and lastly 1. So 1 times x to the power of 0 times y to the power of 6. So it's time to simplify. 1 times x to the power of 6 is times y to the power of 0 is simply x to the power of 6. Plus 6 times x to the power of 5, y to the power of 1 is 6x to the power of 5, y. And 15 times x to the fourth times y squared is 15x to the fourth, y squared. Plus 20 times x cubed times y cubed is 20x cubed, y cubed. Plus 15 times x squared times y to the fourth is 15x squared, y to the fourth. Plus 6 times x to the power 6 times x times x 6 times x times y to the power of 5 is 6x y to the power of 5. And last, 1 times x to the 0 times y to the 6 is simply y to the power of 6. So the answer for this given example, x plus y to the power of 6 is x to the power of 6 plus 6x to the 5 y plus 15x to the fourth y squared plus 20x cubed y cubed plus 15x squared y to the fourth plus 6x y to the fifth plus y to the power of 6. Our next topic is all about arithmetic sequence and arithmetic series. So the only difference between a sequence and a series is that sequence is separated with a comma. However, series is separated by either plus or minus. But in this example, we are using plus. So the common property of a sequence is that it has a common difference. So from here, we have a common difference with plus 2, here plus 2, and here plus 2. So it's the same with here, plus 2, and plus 2. So the only difference is that a sequence, its goal is to find the nth term. However, the series goal is to find the sum of all the given numbers. So, example, we are tasked to find the, let's say, sixth term. So, we are going to use this formula. So, AN. So, AN stands for the missing number, so it is 6. So, A subscript 6 times A sub 1 stands for the very first term, so 1, plus, when we say n, n means that how many terms are there, so there are 6 terms. So 6 minus 1, and we all know that the common difference is 2, so 2. 1 plus 6 minus 1 is 5 times 2. So 5 times 2 is 10 plus 1 is equal to 11. So the sixth term is 11. And the next one is arithmetic series. So when we are tasked to find the, let's say, S7, or the sum from this point here up to the 7th term. So we are going to use this formula. So it's the same with the concept in sequence. N is how many numbers are there. So N is going to be 7. A sub 1, still the first term, 1, plus AN, which is the missing term. So we are going to find S7, so it's going to be 7 divided by 2. So 7 times 1 is 7. 7 plus 1 is 8, 8. 7 times 8 divided by 2. So 56 divided by 2. So S7 is going to be 28. 28. So that is how you find the sequence and the series. So the only difference is that in the sequence you are only tasked to find the nth term. However, in the series you are tasked to find the sum of the whole terms.